As humanity advances, our thirst for space exploration gets ever bigger. 2022 is the biggest year for space launches ever, and as any growing industry, this will eventually leave an ecological mark on our planet. In recent years, there has been a push to make more and more reusable rockets, such as the SpaceX Falcon 9. Just like this drinks can here, once we're done with it, we try not to just chuck it away, but rather recycle or reuse it. It takes a huge amount of energy to first extract material from the ground, refine it, and then turn it into such a can or rocket. However, the same cannot be said about the propellant inside. When a rocket flies, it uses up propellant. When it is reused, this will eventually have to be refilled. The specific chemistries of these propellants and oxidizers can determine how sustainable a rocket is. Throughout history, all sorts of rocket fuels were used, including some which can be found at home, such as this ethanol and water mixture, used in the V2 rocket. Flame can barely be visible. Or the humble potassium nitrate and sugar for homemade rockets, which I've embedded in this piece of paper. Hopefully the smoke alarm doesn't go off. We will compare two of the most successful reusable launch vehicles, the Space Shuttle, which used liquid hydrogen and oxygen in the main tank, and a composite propellant called APCP in the boosters, while the Falcon 9 uses RP1, a highly refined form of kerosene. So which one has a smaller impact on the environment? On a surface level, it seems like RP1 cannot be sustainable as it is a fossil fuel. But some simple maths shows that one Falcon 9 launch releases about 360 tons of CO2. This may seem like a lot, but an average US citizen releases 16 tons a year. Therefore, one rocket launch is equivalent to around 23 Americans. So really, this is just a drop in the ocean in comparison to the 7 billion people on Earth. What is more important is the soot. The Merlin engines on the Falcon 9 do not burn the fuel at an optimal ratio. This leaves some of it unburnt. Soot can be observed at home by simply taking a candle and holding a non-flammable object above it. It quickly turns black, and this black is the soot. Carbon residue, little particles of carbon. Lower down in the atmosphere, soot is still an issue, however nature can cycle it out of the air relatively quickly. Unfortunately, rockets inject soot high into the stratosphere. According to research, stratospheric air to a large extent is decoupled dynamically from the troposphere, and typically takes 3 to 5 years for particles to be cycled out. The APCP solid boosters mentioned previously create a similar effect by leaving small reflective aluminium particles in the air. All these particles create a sort of umbrella around the Earth. This both reflects radiation trying to escape from the Earth, as well as partially block radiation coming from the Sun. The full effect of this insulating layers are hard to predict, but current research says it will probably result in a cooling effect on the surface of the Earth. In contrast, hydrogen-oxygen rockets burn a lot cleaner and mostly produce water vapor. However, this is not without problem. During the launches of the shuttle, high-altitude polar mesospheric clouds called PMCs were seen to form. These are very rare, and it was estimated that one launch created up to 20% of all the PMCs in one season. These clouds also absorb a lot of thermal energy as the droplets freeze and turn into ice crystals. Again, the exact effects of these clouds are unknown, but researchers are worried about affecting the delicate balance of the mesosphere. In conclusion, rocket launches currently have a small impact on the planet. However, with rapid growth, more research will have to be done to see how they will really affect us.